Good evening, students.
Yes, sir. Good evening, sir.
Okay, so in the last class we discussed a few preliminaries regarding the design of induction motor and operation and construction of induction motor. So today I told you that today I will give you the design problems. Okay, so 20 students have joined here. Still, some names I can find in the participants list without any proper naming format. So quickly rename yourself with the proper format. That is last four digit of your roll number followed by your name. Priyanshu, Soham, Sumanto, Aryan, Kumar. So all you try to rename yourself properly, quickly, so that I can start giving the design problems role wise. Ankit Kumar, rename yourself properly. Ankit Kumar, properly rename yourself. Shubhamay বিশ্বাস, rename yourself quickly. Okay, so let's start giving the problems. Ankit, Abhishek, quickly rename yourself. So you
Okay,
just write down the problem format.
okay, sir. Okay.
Can you see the design problem? So you just write down quickly, design a dash kilowatt, dash volt, 50 hertz, dash RPM synchronous, dash induction motor. It is dash connected with efficiency of dash and power factor of dash. So we can write down here the lagging. Okay, so are you writing?
Yes, sir, right.
Okay, so Rupoi Tudu is not there now in the class, so we'll start with Priyanshu Ranjan.
Yes, sir.
Priyanshu, you are muted, okay. So you write down your specifications. Okay, so you have given all the blanks in your design problem.
Yes, sir.
So in the first blank, you write 10 kilowatt. Okay, so
Okay,
it
sir.
will be 10. No, so for okay, so the first roll number, I think first roll number for to do, na Rupoi to do.
Yes, sir.
So for you, it will be 20 kilowatt
Okay, sir.
for 15 volt,
Yes, sir.
1500 RPM.
Yes, sir.
Okay, and then squirrel cage induction motor. Squirrel cage, you just write down in the blank. Squirrel cage,
Okay, sir.
and the connection you will just write delta connected,
Yes, sir.
88% efficiency,
88% efficiency.
0.86 power factor.
Okay.
Power factor of 0.86 lakh
Okay,
as
sir.
written in the problem.
Okay, sir.
Okay. So now Rupoi Tutu has come. Rupoi, unmute yourself.
Yes, sir.
Okay. So you just write down your specification, in the first blank you write 10 kilowatt, 415 volts, 1500 RPM, squirrel cage induction motor, delta connected, efficiency of 88%, and power factor of 0.86 lakh.
Power factor, sir?
0.86 lakh.
Okay, sir.
Okay, in the meantime, Rohit, you quickly take the attendance. Now it is full, I think. Okay. Next roll number is Pratul Boito.
Yes, sir.
You write down your specification. Your roll number is 106,
Yes, sir.
isn't it? Okay. So it's 30 kilowatt,
Okay.
415 volts,
415.
415,
Okay, okay, sir.
1500 RPM,
1500 RPM.
squirrel cage induction motor. Squirrel cage you just write down. Induction motor is already there. Squirrel cage,
Yes, sir.
delta connected,
Yes, sir.
efficiency of 88%, 88% efficiency, and
Okay.
power factor of 0.86.
Okay, sir.
Okay. Next is Ashish.
Yes,
Ashish,
sir.
unmute.
Yes, sir.
What is your surname?
Sir, officially it is no surname, bro.
It's only Ashish.
Yes, sir.
Nice. Now you just quickly write down your specification. Roll number 8, huh? Yours.
Yes, sir. Yes, sir.
Yours is 40 kilowatt,
40 kilowatt,
450 volts,
450 volt.
415 volts,
Sir,
415,
415.
415.
Yes, sir. Yes.
Yes, 415. 1500 RPM,
Okay, sir.
squirrel cage induction motor,
Yes, sir.
delta connected,
Okay, sir.
88% efficiency,
Yes, sir.
0.86, power factor 0.86.
Okay, sir.
What is the next roll number? Shubhodip. Okay. So Shubhodip, write down your specification. Just a minute. 1121. Okay, it's a 50 kilowatt, 415 volts, 1500 RPM, अच्छा 1500 RPM, squirrel cage induction motor, delta connected, 88% efficiency, .86 power factor lag. Next roll number car. Next roll number unmute করো
Hello. Yes, sir.
বলো পরশ
122. Yes, sir.
okay so Porosh, you write down your specification.
Yes, sir.
60 kilowatt 60 kilowatt 415
Sir.
volts
415.
1000 rpm
1000.
1000 rpm squirrel
1000
cage
rpm.
induction motor squirrel cage induction
Cage.
motor ঠিক আছে
Yes, sir.
delta connected
Delta
delta
connected.
connected 88% efficiency
88%.
0.86 power factor লাগে
Sir, 1000 RPM. No, my one is.
yes your synchronous speed would be 1000 rpm
Okay, sir.
next Shubhamoy
Yes, sir. 1, 2, 3.
yes just a minute 1 1 2 3 70 kilowatt
70 kilowatt.
415 volts
415 volt.
1000 rpm 70 kilowatt 415 volts 1000 rpm squirrel cage induction motor
Yes, sir.
delta connected 88% efficiency 0.86 power factor লাগে
Yes, sir.
okay so 0.86 power factor like okay now what is the next roll number
1, 2, 4, sir. Shom Chattopadhyay.
oh,
Yes, sir.
write down 80 kilowatt
80 kilowatt.
yes
Okay, sir.
415 volts 750 rpm
Okay, sir.
750
Yes, sir.
rpm
750, na?
squirrel cage induction squirrel cage induction motor
Yes, sir.
delta connected
Yes, sir.
88% efficiency
88%. Okay, sir.
0.86 lakh
Okay, sir.
next roll number
Yes, sir. 1125.
Ratul
Yes,
Rahul
sir.
na
Ah, sir.
okay so yours is 90 kilowatt
90 kilowatt,
415 volts
415 volt,
750 rpm
750 RPM.
750 rpm squirrel
sir.
cage induction motor
Yes, sir.
delta connected
Yes, sir.
88% efficiency
88%,
0.87 power factor lag
0.87.
0.87 power
Okay, sir.
okay next
Yes, sir. 1128. Prabuddha, sir.
Prabhupada.
Yes, sir.
This is 100 kilowatt
100 kilowatt,
415 volts
415 volts,
1000 rpm
1000 RPM,
Okay, squirrel cage induction motor.
Squirrel cage induction. Squirrel cage. Okay, sir.
Squirrel cage.
Yes, sir.
Your this thing is delta connected. Stator is delta connected.
Yes, sir. Delta connected.
Yes.
Yes, sir.
91% efficiency.
91% efficiency.
Power factor is 0.86.
0.86 lakh. Okay, sir.
Yes.
Thank you, sir.
Next roll number
12010 Shubha.
110 kilowatt,
110 kilowatt.
415 volt,
15 volt.
1000 RPM,
1000 RPM.
squirrel cage induction motor,
Squirrel cage induction motor.
delta connected, 89% efficiency,
89% efficiency.
power factor 0.85.
0.85 lakh. Okay. Thank you, sir.
0.85. Okay. Next is
Sir, Orco
next
130.
roll number
So 130 Orco
120 kilowatt,
120 kilowatt. Yes, sir.
415 volts,
415 volt. Yes, sir.
1000 RPM,
1000 RPM.
squirrel cage induction motor,
Yes, sir.
star connected,
Okay, sir.
89% efficiency,
Yes, sir.
0.85 lagging power factor.
Sir, 0.85. Right. Okay.
Yes.
Thank you, sir.
Okay. Next roll number
1131 Saptarshi.
1131. Saptarshi. Yours is 130 kilowatt,
130 kilowatt,
415 volts,
415 volts,
1000 RPM,
1000 RPM,
squirrel cage induction motor,
squirrel cage induction motor,
star connected,
star connected,
89% efficiency,
89% efficiency,
0.85 lag.
0.85 lakh. Okay, sir. Thank you, sir.
Next roll number
1132 Somadip Basha, sir.
is 140 kilowatt,
140 kilowatt.
415 volts,
কত স্যার?
415, 415,
415,
750 RPM,
750 RPM,
squirrel cage induction motor,
squirrel cage induction motor,
delta connected,
delta connected,
89% efficiency,
89% efficiency,
0.85 lakh power factor.
85 lakh. Okay. Thank you, sir.
Next roll number কোথায়? Next roll number কোথায় গেল?
134 Yash, sir.
Yes, sir. 134 Yash Singh.
Actually, over to me. 150 kilowatt,
150 kilowatt,
415 volts,
415 volts,
750 RPM,
750 RPM,
squirrel cage induction motor,
Squirrel cage induction motor,
star connected,
star connected,
89% efficiency,
89% efficiency,
0.85 lakh power factor.
0.85 lakh power factor. Okay, sir. Thank you, sir.
Next,
Next 135 Shobhik Mondal is absent. After that 137
মানে
Rohit
আছে তো মানে ক্লাস করে তো?
হ্যাঁ স্যার ক্লাস টাস করে আজকে অ্যাবসেন্ট
আচ্ছা ঠিক আছে,
তারপরে স্যার আমার 137 রোহিত কুন্ডু
হ্যাঁ ঠিক আছে। 170 কিলোওয়াট,
স্যার 170 কিলোওয়াট
so you just mute yourself. Just a minute. 170 কিলোওয়াট লিখেছো?
170 তো স্যার
হ্যাঁ 170।
Okay.
415 volts,
415 volts
1000 rpm,
1000 rpm
wound rotor induction motor, WRIM, wound rotor induction motor.
okay sir
Connection would be star.
okay sir
You write two connections, star, because it's a for wound rotor induction motor. For the rotor also, one connection type you have to provide.
okay sir okay
So your connection is star
Yes, sir.
slash star. Okay.
okay sir
89% efficiency,
yes sir
0.85 lagging power factor.
okay sir
Okay, next. After Rohit, who is there?
138 জয়ন্তময়ী
Wait, Shimon. I am unmute. Joyantomoy unmute. ক্লাস করছে না, কোথায় ঘুরে বেড়াচ্ছে? ওয়ান 138 বললে তো? জয়ন্তময় is there? Can you waiting রুমে পাঠিয়ে দেবো? কার দেখতে পাচ্ছ? আচ্ছা তারপরে
আসেনি ও তো
না না ছিল, একটু আগে ছিল, এখন বেরিয়ে গেল।
ও,
139 না? নেক্সট রোল নাম্বার আরিয়ান কুমার।
Yes, sir.
Okay, Aryan, you just write down your problem. 190 kilowatt,
190 kilowatt,
415 volts,
415 volt,
600 rpm,
600 rpm,
wound rotor induction motor, wound rotor induction motor, wound rotor induction motor. ঠিক আছে?
yes sir,
Delta
Yes, sir.
star connected, delta star connected,
delta star,
connected.
yes sir,
Okay, 89% efficiency,
89% efficiency,
0.85 lakh power factor.
0.85 lakh. Thank you, sir.
Okay, so next roll number is Ankit.
Yes, sir.
Okay, so yours is 200 kilowatt,
Okay, sir.
200 লিখেছো?
Yes, sir. Yes, sir.
Okay, 415 volts,
Yes, sir.
600 RPM,
Yes, sir.
own rotor induction motor,
Yes, sir.
star connected,
Yes, sir.
89% efficiency,
Yes, sir.
0.85 lagging power factor.
Yes, sir. Thank you, sir.
Next roll number,
Yes, sir. Anirban, 142.
write down 10 kilowatt,
Sir, 10.
10, only 10.
Okay.
110 volts,
Okay.
110 volt. Okay, 1500 RPM,
Okay.
squirrel cage induction motor,
Okay.
delta connected,
Okay.
87% efficiency,
Okay.
0.87 lag.
Sir,
Power factor.
87% efficiency and 0.87 lag.
87 lag, yes.
Okay. Okay. Thank you, sir.
Next roll number,
sir. Hello.
Okay. So you write down Sumanto. Okay.
Sir.
You write down your specifications 20 kilowatt,
sir.
20 kilowatt,
20 তারপর
110 volt,
okay
110
Okay,
volts,
sir.
1000 RPM,
okay
squirrel cage induction motor,
okay
delta connected,
okay
87% efficiency,
okay
0.87 lag power factor.
okay sir. Thank you, sir.
Okay. Next,
Yes, sir. 45.
45.
Yes. Yes.
Write down 30 kilowatt,
30 kilowatt,
110 volt,
10 volt. Yes, sir.
1500 RPM.
Sir, 1500.
Yes.
1500 RPM.
Squirrel cage induction motor,
Squirrel cage induction motor. Yes, sir.
star connected,
Star connected.
87% efficiency,
87% efficiency.
0.87 lag power factor.
0.87. Okay, sir. Thank you, sir.
Next,
Yes, sir. 46, Ravi Ranjan.
40 kilowatt,
Yes, sir.
110 volts.
110 volts, sir.
Yes.
Yes, sir.
1000 RPM,
Yes, sir.
squirrel cage induction motor,
Yes, sir.
star connected,
Yes, sir.
87% efficiency.
87%, sir.
Yes.
Yes, sir.
And 0.87 power factor lag.
Okay, sir. Thank you, sir.
Next roll number,
Yes, sir. Pawan Kumar.
Pawan Kumar, 47. Okay.
Yes, sir. 47.
50 kilowatt, 50 kilowatt,
Yes, sir.
1
Yes, sir. 50 kilowatt.
110 volts,
110 volt.
750 RPM,
750 RPM. Yes, sir.
squirrel cage induction motor,
Square cage. Yes, sir.
induction motor, star connected,
Star connected.
87% efficiency,
Yes, sir.
0.87 power factor lag.
Yes, sir. Done. Thank you, sir.
Next roll number,
Yes, sir. 148.
60 kilowatt,
60 kilowatt,
110 volts,
110 volts,
750 RPM,
750 RPM.
squirrel cage induction motor,
Yes, sir.
star connected.
Star connected.
Yes,
Yes, sir.
87% efficiency,
Yes, sir.
0.86 power factor lag.
0.86.
Yes.
Okay, sir. Thank you.
Next,
Sir, 149. Shubhajit Day.
70 kilowatt,
70.
110
Volt.
volts,
Okay, sir.
600 RPM,
600 RPM.
squirrel cage induction motor,
Okay.
star connected.
Star connected.
Yes,
Okay.
87% efficiency,
87%.
0.86 power factor lag.
86. Right. Thank you, sir.
Yes. Next roll number,
Yes, sir. 150, Sinjan Patro.
150,
Yes, sir. 150.
80 kilowatt,
80 kilowatt,
110 volts,
110 volt,
600 RPM,
600 RPM,
wound rotor induction motor,
rotor induction motor,
star connected.
star connected.
Yes.
Okay, sir.
87% efficiency,
87%,
0.86 power factor lag.
0.86. Okay, sir. Thank you.
Yes. Next,
151 Spandan.
key 151.
Yes, sir.
Write down 90 kilowatt,
90 kilowatt,
110 volts,
110 volts,
600 RPM,
600 RPM,
wound rotor induction motor,
wound rotor,
star connected,
star,
87% efficiency.
87%,
Yes. 0.86 power factor lag.
0.86. Yes, sir.
Anybody else? এছাড়া আর কেউ আছো?
Sir, Faizan written in chat box.
Faizan?
Has written in chat box. His mic is not working.
Okay, so he has joined, no?
Yes, sir.
His roll number is lateral.
Yes, sir. Yes, sir.
হচ্ছে 1001. Okay, 1001. Just a minute, Faizan. Okay. So Faizan, you write down 100 kilowatt, 100 kilowatt, 110 volt, 750 RPM, 750 RPM, wound rotor induction motor, star connected. Wound rotor induction motor, star connected. 87% efficiency and 0.86 power factor lag. Once again, I'm just reading out Faizan's problem. 100 kilowatt, 110 volts, 750 RPM, that is the synchronous speed. Wound rotor induction motor, star connected, 87% efficiency, 0.86 power factor lag. Okay. It's okay, I think. One fellow is left, that is Jayanto Moi. Jayanto Moi, how are you there? With mic? Jayanto Moi? Okay, so here's some connectivity. Why you are not unmuting properly? So you are muted already. Try to unmute first. Jayanto Moi?
Sir, he has messaged me that he is in the train, so that's why he has some connectivity issue.
Why he is in train?
Maybe
Did you know today the class is scheduled? Okay, so ask him to leave the class, and I will give him problem later. Because while traveling, it is not possible to attend the class.
Okay, sir.
Okay. So I think everybody has his individual problem. Okay. So now we can start a design. Okay. So somebody has, most of you have squirrel cage induction motor, but a few have the wound rotor induction motor as well. So initially the design will be similar. When we'll go for the rotor design, then there will be some difference. Okay. So quickly start your design. As I have already discussed during the decimation design, first you have to calculate the main dimension part. So you have book, na? Ekeshani book. You have.
Hello, sir. Hello, sir.
Yes.
Sir, my name is Jayanto Moi. Sir, there are a lot of network issues. That's why.
But why you are traveling now?
Yes, sir.
I heard that you are traveling now. So during traveling, it is not possible to attend the class with proper network. So that should be clear, na?
Sir, actually, sir, problem ছিল তার জন্য emergency বেরোতে হয়েছে. That's why.
সেটা হলে তো তুমি ক্লাস করতে পারবে না, না? এমার্জেন্সি বেরোলে তোমার ফিজিক্যাল ক্লাস হলে কি করে করতে ক্লাসটা?
স্যার আজকে খুবই emergency ছিল তার জন্য বেরোতে হয়েছে, স্যার.
তুমি পরে আমার থেকে এটা প্রবলেমটা কালেক্ট করে।
স্যার নেক্সট ক্লাসে নিয়ে নেবো স্যার, ঠিক আছে?
নেক্সট ক্লাসে নেবে না, তার আগে নেবে। নেক্সট
ওকে
ক্লাসে
স্যার,
কেন
তাহলে
নেবে?
ঠিক আছে স্যার, তাহলে মেল করে দেবো আপনাকে স্যার।
ইউটিউব স্যার। Okay. So start design. So first the Q part you have to calculate. Q means the kVA input. So kilowatt is given because it's a motor. Okay, so for all the kilowatt rating is given in the problem. From that kilowatt you have to find out the kVA input. So how do you calculate kVA input for a given kilowatt?
By dividing
Quickly.
with power factor.
Only. Only by dividing the power factor will get the kVA input.
Sir, 1 plus 2 eta by 3 eta.
No, that is not required because that is for DC machine. It's okay. Now, for input, actually the rating which is given.
by dividing with efficiency also.
Why?
So
Please,
because
Prabhupada.
Sir, Pawan.
Pawan, okay.
Sir,
Bolo?
because it is given the output power.
Yes. So as the output power is given. So every times for any rating, only the output power is mentioned. So that you should know at this stage. When we call the rating of a machine, okay, or rating of everything, so basically the outputs are given. So output kilowatt is given. First, you have to find out the input kilowatt, then input kVA. For finding out the input kilowatt, you have to divide it by efficiency, and to convert it to kVA, you have to divide it by power factor. So that means the given kilowatt divided by efficiency and power factor. So both you have to divide and find out the Q value quickly. So all you try to find out the Q value, capital Q. Is it done? For all?
Sir, my input power is 150 kilowatt. Sorry, sir, my output power is 150 kilowatt and my input kVA is coming out as 198.28.
It can be.
Okay, sir.
Okay. Next, after finding out this Q, you have to assume 2 or 3 things. What are the 3 things we have to assume? In the last class also I mentioned. For finding out the output coefficient. What is the expression of output coefficient? Quickly tell me. C0, capital C0.
Pi square.
What is the expression of C0? Yes.
Sir, pi square B average AC into 10 to the minus 3.
No, one more thing will be there. Last class I discussed in details. What is that? So our AC machine that would come. What is that? Yes, the winding factor. Okay, so you just write down the expression of C0, that is 11 into kW into B average into AC into 10 to the minus 3. So we should have, or we should assume 3 constants. here. So that is the designer choice. 3 constants you have to assume. What are the 3 constants? Winding factor Kw, specific magnetic loading or average flux density B average, and specific electric loading ampere conductor. So these are the 3 things you have to assume as a designer, and you have to put these values in the expression of C0 to find out the C0 value. Okay, so Kw value you can find, you can take 0.95 or 0.99955. Okay, so 0.95 or 0.955 or 0.96. This type of value you can assume for winding factor Kw. Average flux density you take 0.4 to 0.6, as I already mentioned in the last year. B average 0.4 to 0.6 Weber per meter square. And what is the range of AC ampere conductor? You can choose 18,000 to 38,000. It's a large range. Any value you can assume. 18,000 to 38,000. It's 11. Yes, 10 to the minus 3.
Sir, can you repeat for Kw, like the range?
0.95, 0.96. The C0 value should come in 3 digits, like 150, 200, 210, like that. Okay. So quickly compute C0 value. So it should come in 3 digits, 150 or 200, like that. If it has come, then you go for calculating D square L, which represents the volume of the machine. C0 সবার হয়ে গেছে? Have you all computed C0 value? Okay, so we get any value. So you can approximate, you can round it up.
স্যার আমার 100 কিলোওয়াট মেশিন স্যার আমি এসি ভ্যালুটা কি 20,000 নিতে পারি?
Those who has a higher rating, you can go up to 30,000. So don't choose. Okay, but for you, I think for your efficiency is quite high, no?
Yes, sir, 91%.
Yes, for you, I think you have to keep some lower value. So you take 22,000.
Okay, sir.
I have 170 kilowatt machine and
Okay, sir.
89% efficiency. So can I take in the higher range?
You can take around 28,000 like that.
Sir, for 50 kilowatt machine, I have taken 25,000.
It's okay.
And B average as 0.5 and KW as 0.955.
Okay.
So accordingly, C naught is coming, sir, 131.31.
Okay, so 131 you can take.
Okay.
So once you have calculated C0, so you have to calculate the D square L. So what is the formula for D square L? D square L is the Q divided by C0 into n, small n. Q divided by C0 into small n. So that is the d square L value. So Q already you have obtained Q value, already you have obtained C0 value, and small n value is given, that is small ns. So small ns, capital Ns is given, that is the synchronous speed in RPM. What you have to do? Quickly?
Divided by
Divided by
60.
60.
Yes. Like who has 600 RPM, for them it is 10 RPS. So small n is 10. যাদের 600 RPM synchronous speed আছে তাদের small ns টা হবে 10. So like that you have to compute the small ns value and you have to divide it. Okay, so that means Q divided by C0 into small n. So that will give you d square L value, which represents the volume of the machine, because its unit is in meter cube. And it should come 2 or 3 digits into 10 to the power minus 3 meter cube. So the value of d square L should come 2 to 3 digits into 10 to the power minus 3 meter cube.
Sir, for 120 kilowatt machine, my d squared is coming as 60.40 into 10 to the power minus 3 meter cube. So is it all right?
It is all right, but you have to check your calculation whether, because this is the initial calculation, it should be correct. Okay.
Actually, sir, yes, sir. Sir, actually, my question was while calculating the output coefficient, I have taken the specific electrical loading as 30,000, but you mentioned that for higher efficiency we should take lower values. But sir, with 30,000, my C0 value is coming out as 157. So should I keep that and continue the calculation or reduce it, sir?
Okay, so let's see with these values.
Okay, sir.
Nothing can be predicted so early.
Okay, sir.
Sir, for 10 kilowatt machine, can I take AC as electrical loading as 25,000 and BAV as 0.45?
Yes, 22,000 also you can take. For
Okay,
10
okay.
machine is not an
No, sir. Actually, I have to make C0 3 digit. Sir, if I take lower values, then it is coming in 2.
It's not necessary. It can be 2 digits also.
Okay, okay.
Like the 80 or 90. That is
Okay,
also
okay.
okay.
Sir, for 150 kilowatt machine, I have taken BAV value as 0.5 and my AC value as 30,000. And my C0 is coming out as 156.75, sir. So is it okay?
It's okay.
Sir, for 60 kilowatt machine, I'm taking B average as 0.5 and AC as 25,000. So I'm getting C0 as 130.625.
It's okay. Quickly find out now the d square L value, because today we'll calculate up to the LD. Okay, so all the main dimensions we calculate today.
Okay, sir.
Sir,
Yes.
sir, we are calculating d square L as Q by C naught N. So Q is here reactive power or that apparent?
Apparent power. Why reactive power?
No, sir. Note.
Q is the kVA. Q has the kVA unit. Why it should be reactive? So every time we calculate the kVA for transformer, for all the machines except the DC machine, because for DC machine only one power we have. So everywhere we calculate the kVA input on. kVAR reactive power we don't calculate. Don't use that.
Sir, for 110 kilowatt, my D square is coming at 47.72.
47.72.
Yes, sir.
or 110.
Yes, sir. 110.
তুমি সব বেশি বেশি ধরেছো মনে হচ্ছে।
হ্যাঁ 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 ওই
মানে
মানে বিএভিটা ওই এসিটা আমি 35,000 নিই।
35 তো ওটা একটু কমিয়ে দাও, অত 110 কিলোমিটারের জন্য অত বেশি যাওয়ার দরকার নেই। ইউ টেক তো 28,000।
ওকে স্যার।
সেই জন্য তোমার মেশিনের সাইজ ছোট হয়ে গেল।
ওকে।
Sir, for 80 kilowatt machine, my D square is 81 meter cube.
It's okay.
Okay, sir.
Sir, for 50 kilowatt, it is coming around D square L value as 40.34 meter cube.
50 kilowatt.
Yes, sir.
What is the RPM? No,
750.
it is also the volume is also related with the RPM. When we'll go for low RPM machine, the size will be more.
Sir, then it is of
Okay, so what is your RPM?
750 RPM. 750 RPM, sir. Yes, sir.
750 RPM. What is the size you are getting? D square L?
40.34 meter cube.
B average and AC?
B average
What do you have
0.5,
assumed?
0.5 or
Okay.
AC 25,000.
Okay. So you just take your calculation.
Sir, it is wrong. Or
I don't know. You just check once again.
Sir, I have a 170 kilowatt machine and 1000 RPM. And I am getting D squared L as 92.3 meter cube.
হতে পারে, কিন্তু তোমার স্পিডটা অনেকটা বেশি। মানে
মানে স্যার D squared L একটু বেশি আসার কথা, আরো বেশি আসে?
হ্যাঁ, না না, বেশি আসার কথা নয়, কেননা তোমার তো স্পিডটা বেশি।
হ্যাঁ স্যার।
স্পিড বাড়লে তারপর তোমার এটা কমে যাবে, ভলিউমটা কমাতে হবে, ইনার্শিয়াটা কমাতে হবে।
আচ্ছা আচ্ছা আচ্ছা, ওকে স্যার, ওকে।
Sir, sir, for 20 kilowatt machine, speed is 1000 RPM. I'm getting D square L as 19.2 meter cube.
Huh?
9.2 meter cube for D square L.
20 kilowatt.
Yes, sir.
Okay. 1500 RPM, na?
Sir, 1000 RPM.
1000 RPM. আসতে পারে। Just check
Sir,
your
for
calculation.
60 kilowatt machine, I'm getting D square L as 28.73 meter cube.
60 kilowatt.
Yes, sir. 1000 RPM.
60 kilowatt 1000 RPM তো কমই আছে। তুমি B average আর AC কত ধরেছো?
Sir, B average 0.5 or AC 25,000.
Okay, so if your calculation is okay, then you can proceed with this one.
Sir, for 70 kilowatt machine, 1000 RPM, I'm getting D square LS 37.9.
Okay.
Hello, sir. For 10 kilowatt and 1500 RPM machine, I am getting D square L as 6.32 meter cube.
6.32 meter cube.
Means D square L I am getting.
6.32 into 10 to the minus 3.
Yeah, sir. 10 to the power minus 3.
So why you are not mentioning that?
Okay.
6.32 is huge size.
No,
meter
sir.
cube.
Yeah, sir. 6.32 into 10 to the power minus 3 meter cube. So, sir,
So what is
correct?
what is kilowatt rating?
Sir, 10 kilowatt and 1500 RPM.
It's okay, I think.
Yeah, sir. Because I have taken the lowest range of B average and also AC. So that's how it is coming. 6.32. Okay.
Sir, for 150 kilowatt machine and 750 RPM, sir, I'm getting D square L value as 101.19 into 10 power minus 3 meter cube.
Sir, for 110 kilowatt, I am getting 47.72 meters. Sorry, sir, 59.65. 59.65.
110 RPM, 1000.
1000.
Okay.
আমাকে একটু বার করলে আমি কমাতে পারবো কারণ আমার আমি একটু কমাতে পারবো।
না ঠিক আছে।
ওকে
ঠিক আছে, পরে এখন এত আর্লি বয়ে যাবে। ঠিক আছে, মনে হচ্ছে এখন পরে বয়ে যাবে। তুমি ক্যালকুলেশনটা ঠিক করে চেক করে নাও। আচ্ছা, now you all calculate the L and D value. That means how do we segregate L and D? By assuming the proper value of L by tau. Can you remember?
Yes, sir.
So length by pole pitch ratio L by tau. So L by tau you can take 1 to 4. So accordingly you can calculate. Though it is in the book, it is given lower range, but you can go up to 3 or 4. L by tau.
Okay.
So tau is basically pi d by p. So that will give you basically L by D ratio. But the thing you have to assume is L by tau. তোমাদের যেটা assume করতে হবে, that is L by tau ratio. Okay. So L by tau ratio you can assume 1 to 3 or 1 to 4. So
একটা question.
1.5. These are the value you can take. Yes.
Sir, one question. Sir, how are we deciding the D square L is correct or not? I mean, what is the factor that for the calculating D square L? I mean, মানে আমরা কি করে বুঝছি এটা ঠিক আছে না ভুল হয়েছে মানে
Rating of the
হ্যাঁ মানে
তোমাদের ক্যালকুলেশন যেরকম হবে সেরকমই হবে। এবার ব্যাপারটা হচ্ছে এখানে তো তোমার শোনো, ক্যালকুলেশন যদি ঠিক হয়, এবার ব্যাপারটা হচ্ছে তোমার ডি স্কোয়ার এল যদি খুব ছোট আসে, হ্যাঁ, সেক্ষেত্রে তুমি ধরো তুমি খুব বেশি ভ্যালু ধরেছো, সেক্ষেত্রে ডি স্কোয়ার এলটা অনেক ছোট হয়ে গেল। সেক্ষেত্রে এল আর ডিটা বা ডিটা এমন এলো যাতে তুমি তোমার কন্ডাক্টর গুলোকে অ্যাকোমোডেট করতে পারছো না। সেক্ষেত্রে ইউ হ্যাভ টু এগেন রিভাইজ the assumptions like B average AC so that you can get some space to accommodate your conductors.
Okay, মানে
এইভাবে
বেশি হয়
বাকিটা তো
মানে কিউ এর ভ্যালুটা যদি বেশি হয় তাহলে টেকনিক্যালি ডি স্কোয়ারটা বেশি হওয়া দরকার, আর যদি আরপিএমটা বেশি হয় তাহলে ডি স্কোয়ারটা কম হওয়া দরকার, তাই তো?
ডি স্কোয়ার এল যদি বেশি হয়, ডি স্কোয়ার এল খুব বেশির দিকে গেলে তোমার মেশিনের ভলিউম বেড়ে যাচ্ছে, মানে তোমার মেশিনের কস্ট বেড়ে যাবে। You need more iron and more copper. So that means though you are efficiency wise you are doing very good design, but your design will not be accepted because it will be having a higher cost, because D and L is this basically the D square L is the deciding factor of the cost of the machine, isn't it?
Okay.
তোমার মেশিনের ভলিউম যদি বেড়ে যায় তাহলে সেই জন্য আমরা একটু অপটিমিস্টিক ওয়েতে একটুখানি বেশি বেশির দিকে যদি এভারেজ ফ্লাক্স ডেনসিটি এটা একটু বেশি দিকে ধরি, হ্যাঁ বইতে অনেক কম কম দেওয়া আছে দেখবে। তো আমরা যদি একটু বেশির দিকে ধরি তাতে হয়তো একটুখানি তোমার টেম্পারেচার রাইজ বেশি হবে বা এ হবে, কিন্তু তোমার কস্টটা কমবে আর কি। কিন্তু যাদের এফিসিয়েন্সিটা অনেক বেশি আছে তাদেরকে একটুখানি বেশি স্পেস আগে থেকে ধরে রাখতে হবে, এরকম ভাবে আর কি। ভাবে তো ডিজাইনে এরকম কিছু একদম থাম রুল বলে তো কিছু হয় না। ওকে, সো ইট বেসড অন দ্য এক্সপেরিয়েন্স।
Sir, mine is 100 kilowatt machine, 1000 RPM and 91% efficiency. Sir, D square L is coming 66.35 into 10 to the power minus 3 meter cube.
1000 RPM and
The 100 kilowatt, 1000 RPM and 91% efficiency.
it can yes, it can be like that.
Okay, sir.
So
Thank
for
you, sir.
150 kilowatt machine, 750 RPM, sir, my D square L value is coming out as 101.19.
7?
Sir, 150 kilowatt, 750 RPM.
Yes, it can come like that. Yes. So anything, I already told anything 2-digit or 3-digit value. Just 3-digit means just above 100 and or 2-digit value, and sometimes for very low kilowatt it can also come low kilowatt and high RPM, like 10 kilowatt, 20 kilowatt and 1500 RPM, 1000 RPM. It can even come below 10. Okay.
Okay, sir.
So into 10 to the power minus 3 meter cube. So everything is okay. Only you have to check your calculation because it's a very initial calculation, and this is the most important calculations of a machine which decides the volume of your machine. So once you have calculated the D square L, then you have to segregate D and L by assuming proper value of L by tau ratio. So tau is given by pi D by P. D is the diameter and P is the pole of the machine. Again, D is the diameter of the air gap. Okay, so mean diameter of the air gap. Okay, so you just write down L by tau equals to some value you assume between 1 to 3. L by tau টা 1 to 3 এর মধ্যে একটা ভ্যালু অ্যাজিউম করো, করে tau এর instead of tau you write pi D by P. From that you will have a ratio L by D. So D square L already you have obtained. Now from this expression you will have L by D. From these two expression you can calculate L and D. হ্যাঁ, পিটা তো সবারই তো জানাই। পি আছে যাদের 1500 আর 1500 RPM, they have 4 poles. যাদের 1000 RPM, with that you should মানে এগুলো তোমাদের তো একদম দেখেই বলার কথা। 1000 RPM হলে 6 পোল, 750 RPM হলে 8 পোল, 600 RPM মানে 10 পোল। পি আবার আলাদা ক্যালকুলেট করতে হয়। 1500 RPM means 4 pole, 1000 RPM means 6 pole, 750 8 pole, and 600 10 poles.
Sir, for 120 kilowatt machine and 1000 RPM, my D value is coming as 390 millimeter and L is 408 millimeter.
It's okay. You just see one thing, that your L and D value should not deviate too much. Like just now told that his value is 300 and 280, it's acceptable.
Sir, my values are deviating by 18.
It's okay.
Yes, sir.
That should come near. So up 58, 50, 60, this millimeter difference is acceptable. but you have to be careful with the units because it will be in a 3-digit millimeter or 2-digit millimeter. For low machines, it will be 2-digit number with having the unit millimeter. So you should not exceed 600 mm. যে রেটিং আমি দিয়েছি তোমাদের এল আর ডি মানে ভ্যালুটা 600 mm এক্সিড করার মতো নেই কোথাও। So that you just check. So up to this L and D you have to calculate today. The rest of the thing you will start in the next class. Quickly, Faizan.
So for 80 kilowatt machine, my D is 441 millimeter and my L is 415.442 millimeter.
কত বললে?
D is
না রেটিংটা কত বললে? রেটিং আর RPM-টা বলো।
Rating 80 kilowatt, RPM 600 RPM.
আচ্ছা তাহলে ঠিক আছে।
Okay, sir.
600 RPM means your machine is slow machine. Okay. Okay. So your D square L also more than 100?
No, sir, my disco L is around 81. 81 10 to the power minus 3.
Okay. Faizan, have you done something? Faizan. Okay, so his mic is having problem.
Sir, for 100 kilowatt machine, 1000 RPM, sir, my D is coming 398.66 millimeter and L is coming 417.476 millimeter.
Okay.
Thank you, sir.
Sir, for 110 kilowatt, my D is 384 and L is 402.
Okay. What are the L by tau ratio you are generally assuming?
Sir, 2, sir.
Okay. Okay. No issue. Okay. You just you have to just see one thing that actually this L by tau ratio in book some suggestion, some guidelines are given. You can consult that. But in real life, when we design, because you are in the final semester, so I should tell you that in real life, when we are supposed to design a machine, we are generally given some the frame size. Okay, so there are standard NIMAS frame size is given. So when we have to design with a specified frame size, then your L and D ratio, these things are already specified. Okay, then you have what you have to do, you have to retrofit your D and L with proper B average and this thing. So there you cannot meet the L by tau ratio. Okay, so therefore the range which is given in the book it's okay for pre-design, freehand design, but when the frame size is given, then it would not be possible every time to maintain that L by tau ratio up to 2. So you can exceed the L by tau ratio beyond 2 also. Okay, no issue in that. বুঝতে পারছি আমি কি বলতে চাইছি?
Hello, sir. Sir, 10
Yes.
kilowatt and 1500 RPM এর জন্য স্যার D টা আসছে 175 মিলিমিটারের মতো আর L টা 206 মিলিমিটার।
কত কিলোওয়াট?
10 kilowatt and 1500 RPM.
আচ্ছা।
So 175 D আর L টা আছে 206.
হ্যাঁ ঠিক আছে।
Okay.
হ্যাঁ কত কথা বললে আরেকবার বলো। L by tau ratio কত ধরেছো? না তোমার কত আরপিএম বললে? না না, ঠিক আছে, না আমি ছেড়ে জিজ্ঞেস করছিলাম তোমার লেন্থ কত এসছে বললে? 36? ওকে, তোমার লেন্থটা না বড় হয়ে গেছে রেসপেক্টে। তো what you do, you assume L by tau such that your L by D ratio is around 1.2 or something like that, or 1.1. Yes, that you can take. For small machines are okay.
Sir,
Sir,
for
for
150 kilowatt machine and 750 RPM, sir, my D value is coming as 505.14 millimeter and L is coming out as 396.53.
L 396.
Yes, sir. And D is coming out as 505.14. So my RPM
That is also,
750.
yes, that is also, you are deviating D too much.
Can the diameter be slightly greater than the length?
Yeah, yes. That is
So
possible.
okay, so for my 170 kilowatt machine, 1000 RPM, I am getting diameter as 416 millimeter and length as 414 millimeter.
These values are quite good.
Sir, for 40 kilowatt, diameter is coming around 371 mm and length is 291.
Sir, for 20 kilowatt and 1500 RPM, I am getting D as 204 millimeter and L as 241 millimeter.
Okay.
The D value of 505.14 and L of 396.53 millimeter is okay.
Just a minute. Yes. Yeah. It's okay. It's okay.
Sir, my L by D ratio is 0.785.
L by D ratio.
Yes, sir. 0.785, sir. Sir, my RPM is 750, so my number of poles is coming around as 8.
No, L by D ratio should come near about 1 or little more than 1 also it's okay because you're low RPM.
Sir, my kilowatt is, sir, 150.
So therefore I'm asking, your kilowatt is 150. So if your L by D ratio is quite low, okay, so it will having very high inertia because inertia depends on the L by D ratio.
Yes, sir. So, sir, my D value is coming around as 505.14 and L is coming around as 396.53. So, sir, sir, my L value is
What is the L by tau ratio you have assumed?
So L by tau ratio I have assumed as 2.
So you can increase a little bit.
So should I take 3?
Yes, you can take 3.
Okay, sir. I will take 3.
So for 70 kilowatt, 1000 RPM machine, so I'm getting D as 289 millimeter and L as 454 millimeter, and L by D ratio is 1.6.
কত?
Sir, for 70 kilowatt and 1000 RPM.
ঠিক আছে, হ্যাঁ বলো তোমার এটা বলো
L by D ratio. Sir, 1.6.
L by D, L আর D টা বলো।
Sir, L হচ্ছে 454 আর D হচ্ছে 289.
না এটা তোমার L by D রেশিওটা L by tau রেশিওটা বাড়াও 2 করো 2 করো বা 2.5 করো করে চেঞ্জ করো।
Sir, for 90 kilowatt, 600 RPM machine, I am getting D equal to 460 millimeter and L equals to 433 millimeter.
Okay, so we'll end the class today because it's already 8 o'clock. So, Sugato, this Tuesday evening it's a fixed slot, no?
Yes, sir.
Yes, sir.
Unless you are having some placement. So your plan started?
Sir, almost.
Huh?
Almost end, sir.
Almost end.
I mean, sir, this year, I mean, till now, 94 students have been placed in electrical.
Okay, so including all companies.
Yes, sir. Total we have 123 students.
Yes, sir. No, sir, there are মানে এখনো অনেকগুলো ড্রাইভ চলছে, অনেকগুলো কোম্পানি এখনো মানে ভিজিটে আছে, মানে এখনো অনগোয়িং ক্যাম্পাস চলছে।
না আমি জিজ্ঞেস করছি যে 92 টা যে এর মাস রিক্রুটার গুলো নিয়ে মানে টিসিএস এগুলো নিয়ে
মাস রিক্রুটার বাদ দিলে ওই 4/86 এরকম হবে যদি মাস রিক্রুটার বাদ দিই।
আচ্ছা কোরে কিরকম হয়েছে এবার?
কোরে অনেক, 38 জন কোরে।
পিওর কোরে
আমি স্যার মানে বুঝলাম, আমাকে জিজ্ঞেস করলেন মানে আমি করে কিনা?
না তুমি করে না, আমি বলছি যে কোরে কজন হয়েছে? 38
জন মতন করে।
আচ্ছা, হ্যাঁ ভালোই হয়েছে এবার তাহলে ক্যাম্পাসিং। লকডাউনের সময় তো এতটা ক্যাম্পাসিং হয়েছে। হ্যাঁ, এখন ব্যাপারটা হচ্ছে ক্যাম্পাসিং করে তো অনেকে আবার হাই স্টাডি করতে চলে যায়, ফলে বাকি যে 30 জন এখনো বাকি আছে তাদের
সবাই বসছে না যদিও, মানে এখনো মানে বেশি মানে বাকি আছে বলতে গেলে 12 থেকে 13 জন, মানে তারা মানে সবাই বসছে না, মানে 122 আমি টোটাল ক্যাপাসিটি সবাই বসছে না প্লেসমেন্টে। আচ্ছা, একদম
প্লেসমেন্ট কোঅর্ডিনেটর কে ওই এরা অনিশ তোমাদের?
হ্যাঁ স্যার,
অনিশ না?
ইয়েস স্যার, অনিশ আর প্রতীক।
প্রতীক হচ্ছে স্যার সেন্ট্রাল প্লেসমেন্ট কোঅর্ডিনেটর।
ও আচ্ছা, ঠিক আছে, তোমরা তাহলে মানে লকডাউনে তো তোমরা একটা চাকরি নিয়ে বেরোবে, এটা খুব ভালো একটা নিউজ। ওকে, at the same time you are also attending the class regularly, I think.
Yes,
Huh?
yes, I was trying, sir. Regularly.
And those who are preparing for GATE next month, only I think only 15 days or 2 weeks left for GATE exam, na?
8 তারিখ স্যার, 10 দিন
Who
আছে।
are preparing for ও 10 দিন, 5 তারিখ, এবার আরো আর্লি। আচ্ছা, তো যারা যারা গেটের প্রিপারেশন দিচ্ছ, মানে গেট পরীক্ষা দিচ্ছ, তাদের প্রিপারেশন কেমন হয়েছে? ওকে, so that means silent.
কেউ আছে কি নেই জানি না স্যার।
স্যার আসলে প্রথমের দিকে গেটে দিয়েছিল, তবে প্লেসমেন্টের পর একটু মানে প্লেসমেন্টের সময় অনেকটা গ্যাপ হয়ে গেছে প্রিপারেশনে, তো জানি না কিরকম হবে।
হ্যাঁ স্যার।
মানে প্লেসমেন্টে প্রায় 3 মাস গ্যাপ হয়েছে।
হ্যাঁ স্যার, প্লেসমেন্টের জন্য একটু গ্যাপ হয়ে গিয়েছিল স্যার।
You are not appearing for GATE, Prodha?
হ্যাঁ স্যার, হ্যাঁ স্যার, স্যার I am appearing sir.
Are you prepared?
Yes sir, I prepared sir, but due to placement sir, the preparation was not very good sir.
For any other exam apart from GATE?
Yes sir.
UPSC Engineering Service next year, anybody is planning?
Yes sir.
Next year how many are planning for UPSC?
I am sir.
Sugato?
Yes sir.
Okay, so you should prepare for UPSC Engineering Services exam, because that is the main, in my opinion, that is the one of the respected job in under Indian government.
মনে একটা ডাউট আছে,
most
ইউপিএসসি
বলো।
এর জন্য প্রিপেয়ার করব না ইএসসি এর জন্য, সেটা নিয়ে এখন একটা ডাইলেমা আছে। তো সেটাই ইউপিএসসি সিএসসি মানে সিভিল সার্ভিস নাকি ইএসসি?
Yes sir.
ESC.
Engineering
yes.
service. Engineering service, you should prepare for engineering service. আচ্ছা, আরেকটা জিনিস বলি যে ইঞ্জিনিয়ারিং সার্ভিসটা কিন্তু মানে খুব টাফ এক্সাম নয়, কিন্তু যেটা লাগে সেটা হচ্ছে এখানে তোমার কি বলবো, মেনি থিংস, মানে মেনি আদার থিংস ম্যাটার, মানে তোমার এখানে ডেসক্রিপটিভ কোয়েশ্চেন্স থাকে। তো তুমি কতটা পুরো 4 বছরে কি কি শিখলে সেইটা কিন্তু ম্যাটার করে ইঞ্জিনিয়ারিং সার্ভিসে, বুঝতে পেরেছো? সুতরাং ইঞ্জিনিয়ারিং সার্ভিস পেতে যে ভীষণ মেরিট, হাই কিছু মেরিট লাগে তা না। সো মানে আমার মতে তোমাদের অনেককেই ইঞ্জিনিয়ারিং সার্ভিসে বসার কথা, তোমরা কেন বসো না আমি জানি না। ইউ শুড প্রিপেয়ার লাইক বিফোর, নট নাও।
হ্যাঁ স্যার, নেক্সট ইয়ার
আগে থেকেই তোমাদের ইঞ্জিনিয়ারিং সার্ভিসে প্রিপেয়ার দেবে, বাট হ্যাঁ। ওকে, সো থ্যাংক ইউ ভেরি মাচ, গুড নাইট, prepare for
Thank you
GATE.
sir.
Thank you.
Okay, sir. Thank you, sir.
Thank you sir.
Thank you, sir.